So it's day 40. We are doing regarding exponents and logs. We're doing real-world word problems with exponents and logs. We've already done word problems, you're thinking, because we have. When we did it last time, the calculator and found the intersection, right? We had a exponential function, and then we said sometimes we were given a value, and so we graphed that too. So there was y1 on the calculator, and this was y2, and we graphed an intersection point, and we were able to find out value, which was often a when, and the y value, which was a variety of things. Okay, so we did this using that intersection, second calc 5, enter, enter, enter. Okay, now we're going to use basically pencils. Now this actually, instead, so we're going to do this by hand. Now this actually doesn't mean we don't calculator at all. It's just that we're not putting into equations and finding out where they intersect. We're solving it by hand, and then sometimes, like when we do the log base 4 of 56, we use the calculator for something like that. That's what we're doing here. But in this other ways, it's very similar to what we've done in the past. Okay, so first problem. In January 1993, there were about 1,313,000 internet hosts. During the next 5 years, the hosts increased by about 100% per year. So a couple things should come to mind. First of all, whenever it gives us a date, we have to say, okay, t equals 0 is 1993. So if we're asked when, we relate it to 1993, t is 0. Now, there were about, okay, this is over 1 million. So we're going to refer to this is 1.13 million. Okay? Instead of all the zeros. During the next 5 years, so really that is only valid for 5 years, the number of hosts increased by about 100% per year. Well, we rate, and when we do rates, we just take this and we move it over 2 places, right? So 100% would be equivalent to r equals not 1, just 1, right? We move that decimal place over 2 places. Okay, so 1%. So what I also want you to think is which of our, remember we had that list of equations, which one would be the best to use here? So I'm going to put that in a different, okay, I'm going to put that in pink. And the equation is going to be a equals p times 1, we're increasing, plus r to the t. It's the equation we should use. All right, model, giving the number in millions, h, of hosts t years after 1993. Okay, so we start with 1.13 million times 1 plus r. So it's 1 plus 1, okay? So we've got h equals 1.313 to the t. That is the, okay, there's the model, the equation. When, that's a t value, will there be 25 million internet? So I've just been given my y2. What do I do with it? I don't put it in the calculator, but I do this. There's the equation, so I'm going to say 20 million, there's my y2, equals 1.313 times 2, okay? So now I quote by hand. Okay, so first thing I want to do, I look at that and I say, okay, there's my exponent, I want to isolate it. So the first thing I'm going to do is divide by 1. Then do that on the calculator. Now here's where we're going to use our calculator. But I need a graphing calculator for this, 25.313, both referring to millions. My answer is 1904. 19.04 equals 2 to the t. Well, now what do I do? Well, I've got this here to do is I'm going to take the log base 2 of this side and the log base 2 of this side. Well, these will cancel, giving me equals, this is a number on my calculator. So I go to my calculator, I hit math. You can do that, sorry, that helps. Scrolling up to the log base function, and I'm going to say the log base 19.04, 4.251. T equals 4.25. I'll go to 3 places. Okay? Okay, the question is when. All right, and this is years. So it's really a little over 4 years. 1993 plus the 4 years. So this is gonna, when will there be in 1997? Okay? All right, let's move on. All right, you buy a new car for $24,000. The value decreases 16% a year. Okay, so I say, what formula will I use? A equals the initial 1 minus R. Now do the model. So I've got A, the amount that worth equals 20,000. We could write that as 24. Let's just write it as 24,000. Now it's 1 minus R. So 1 minus 0.16 equals 0.84. Okay? So I'm going to put here 0.4 to the t. Okay? Now, when will the car be worth 8,000? I plug 8,000 in here, equals 24,000 times 0.84 to the t. Okay, now I'm going to solve it. What will that happen? Well, first I divide out 24,000. Okay, and this reduces to 1/3. Okay, these cancel completely. So now I have 1 equals 0.84. Well, what do I do now? Well, now I want to get rid of this 0.84. It's a base of an exponent, so I can call it the log base 0.84 of that side and log base 0.8 side. Okay, so now just do the math on your calculator. So when I'm getting 6.301 equals t, because these two cancel 6.301. Right? So the question is still not answered. So I would say in years is the answer to my question. You deposit $5,000 into an 5% that is being compounded monthly. What formula should come to your mind? Well, equals the initial amount, 8, over the number of times I'm compounded per year, n. Okay, 12. R equals 0.045, and the value. Okay, I'm going to make a model. A equals 5,000 times 145 over 12, right, over n, to the, okay, that's my model, and that's the answer to that. When will your account reach 7,500 in? 75 equals 5,000 times, now, because this is all, right, this is just a number, let's just add this together. I'm going to put this into my calculator, and I get, when I do that, I get 0.0375. 1 plus that, 0.00375 12t. Get to the t, so I'm going to divide out the 5,000, divide out the 5, the whole thing cancels, divide by 5,000, okay, and you're going to get, so 75 over 50, equals 1.00375 to the 12t. These numbers are getting funky, but it's the same process as always. I have a base, I want to get, so I'm going to take base 1.00375 and the log 1.00375 of the right, and we know what happens, cancels. My calculator, okay, so I plug that into the calculator, and I'm going to get, when I do plug that in, okay, so math up to, okay, there, plug it in, 1.00375, move over, okay, and I enter, 8.327, okay, so 8.32 to 12t, now I'm going to divide both sides by 12, so we've already divided by 12, 0.027. 9.02. So we're, the question is, will your account reach 7,500? So 9 years, 500 at this rate of interest. Okay? Let's keep. You know what? I am going to stop this actually, and then we'll